Okay, Assalamualaikum and good morning to all of you. Today I will explain how to solve the tutorial number 4. Okay, the question is a car has a weight of 1901 Newton in the front axle and 1552 Newton on the rear axle with a wheelbase of 2.5 meter. And then this table shows the tire cornering stiffness values, okay, for uh, respective loads. Okay, based on these parameters given, you are required to determine or find the cornering properties of the vehicle, with parameters from A until G. Okay, first A, you need to determine the anchorment steer angle for different turning radius. Okay, you have 15, 30, 60, and 150 meter turning radius. So for each turning radius, you need to determine the Ackermann steer angle. Okay, so you can refer to your lecture notes regarding chapter number 6, steady state in cornering. So to solve the Ackermann angle, for example, with the 15-meter turning radius, okay, so this is the formula. Wheelbase divided by the turning radius. So the vehicle wheelbase is 2.5 meter, divide turning radius, for example, 15 meter, you get certain value, okay, in radian. But normally, when we express the angle unit in degree, so you need to convert the radian to degree by multiple the x value with 150 degrees over pi. So lastly, you get the Ackermann steer angle at 15-meter radius. Okay. So to solve the other turning radius, 30, 60, and 150, you can using the same method. Okay. First, you need to determine the radian first, and then you need to convert it to the degrees. Okay, and then we go to the next question, which is to determine the understeer gradient. So based on your lecture note, the understeer gradient can be expressed as this equation. Okay. Okay. In order to find the understeer gradient, okay, we must know the cornering stiffness of the tires at the front load. Okay, for example, at the front axle, the tire load is the tires load is 1901 Newton. So for one tire, you need to divide by 2, right? Divide by 2. So at the front axle, okay, one tire only, one tire. You need to divide the front axle weight to 2 to define the weight at one tire. Okay. So the value is 950.5 Newton. Right? For the rear tire, same method. We need to determine only one tire weight. So WR in one tire. The rear axle weight is 1552 Newton. You need to divide by 2. So you get 776 Newton. Okay, so for example, at the front tire, okay, uh, the one tire load is 950.5 Newton. It lies between 9,000 and 1,125 Newton. So based on one tire load, you need to determine the cornering stiffness C alpha F for at the front tire by using the interpolation technique. Okay, so you must get the values must be in between 225 and 257 Newton per degree. Okay, so when you solve the cornering stiffness, right, later you will get C alpha F equal to 232 Newton degree and C alpha R 195 Newton degree. So based on these values, okay, plug in to the equation under steric gradient. So you can solve number B equation. Okay, then the next question is to find the characteristics value of speed. Okay, so based on lecture notes, the equation is V characteristic equal to square root of 57.3 LG over K. Okay, so L is the wheelbase, G is the gravitational force or acceleration, and K is the understeer gradient. So you can solve number C. Right? Okay, D, the lateral acceleration gain at 60 km per hour. So based on the lecture note, the equation quite long. Okay, I just write down. This is the lateral acceleration gain quotient. Over okay, so this is the lateral acceleration gain. Okay, V given at 60 kilometer per hour. Okay, and then the velocity you need to convert to meter per second first. Okay, for example, z is the value, meter per second. So you just plug in the value, speed, wheelbase, gravitational acceleration, understand gradient into this equation. So you can solve the lateral acceleration gain at 60 km per hour. Okay, for E, based on your lecture notes, the equation of yaw rate gain. Okay, this is the equation of yaw rate gain over L 1 plus KB square. So this is the equation to solve equation E, which related to yaw rate gain when the car reaches the speed of 60 km per hour. Okay, so with the same value, velocity in meter per second, L is the wheelbase, K is the gradient, G is the gravitational acceleration. So you can solve the question number E. Okay. And then regarding question number F, right? Question number F. So the number F is to determine the slight slip angle at the center of gravity on a 250 meter radius turns at 60 km per hour. Okay, the question is the slight slip angle is beta equal to 57.3 T over R, okay, minus W R V square over C alpha R G R. Okay, so C we can determine by using WFL over W. Okay. C is the distance between center of gravity to the rear axle. Okay. So WF is the front axle weight, which is 1,901. Okay, 1,901 Newton times wheelbase 2.5 meter over the vehicle weight. Okay, how to determine the vehicle weight? Just add the front weight and rear weight, rear axle weight, rear axle weight 1552. Okay, R is the turning radius at the value is 250. Okay, V is the speed, okay, in meter per second. G is the gravitational acceleration. WR is the rear axle weight. C alpha R is the value when you determine at equation B here, C alpha R. Okay, C alpha R. So you can plug in all the values and you get the slight slip angle, okay, in degree. Okay, lastly, for the static margin, okay, so this is the equation for the static margin. Wheelbase, let me write below. So wheelbase times C alpha F over C alpha F plus C alpha R. Okay, the wheelbase is 2.5 meter. Okay, C alpha F is 232. Yeah, this value. 232 Newton degrees. Okay, you can choose this value. And C alpha R is 195 Newton per degree. Okay, and then you can um, solve or find the static margin of the vehicle in meter. For example, value A in meter. Okay, thank you very much. That's all.